Good morning, Ananda. I, Siddhara GN, Assistant Professor, Department of Civil Engineering, VKIT. I welcome you all to the third day of webinar on Design and Construction of Steel Structure. I welcome today's speaker, Mr. Abhilash Joseph, AVEVA Group PLC, Mumbai, for this webinar. Welcome you, sir.
Thank you.
I welcome Mr. A.K. Samantha, General Manager, Mechanical, INSDAG. Welcome you, sir. And also I welcome Dr. C.S. Shashikumar, HOD, Department of Civil Engineering, VKIT, and faculties of Civil Engineering Department, VKIT, and all the participants for today's webinar. Now it's my pleasure to introduce about today's speaker, Mr. Abhilash Joseph. Mr. Abhilash Joseph is a fine business professional who has built three distinct fabrication software business across the Asia-Pacific regions. His vision is to support and work for the modernizations and automation of steel fabrication industry. He has 25 years experience in steel fabrications and software industry. He is a state rank holder in mechanical engineering. He was born and bred in Kerala. He has worked in Bangalore, Dubai, London, and Mumbai for various business assignments. He has visited over 45 countries for various business engagements. Presently, he is working with the senior sales management team of AVEVA, a UK-based software MNC in Asia Pacific region. Now I request Dr. Sashikumar sir to talk a few words about these sessions. Over to you, sir.
Thank you, Siddharaju. I think nowadays the steel structures are coming up in a large scale, maybe in the form of high-rise buildings or PEBs, etc. Samantha sir has actually thrown light on the fabrication yesterday, and he has given insight on what are the constraints that are there in the fabrication. And he has told yesterday that the site fabrication is completely ruled out, and we have to go for fabrication in the factory. In the factory also nowadays, you require more number of employees for fabrication work, and I think if we employ automation in factories, I think it will help the factory, the fabricators to provide good quality fabrication and also reduce the manual error. So I think on this aspect, we have today with us Abhilash Joseph sir. He is from AVEVA Group, and I welcome him to this webinar, and I also thank him for accepting our invitation.
You went on mute, Mrs. You went on mute automatically.
Yeah, I would welcome Dr. Abhilash Joseph for this webinar, and I wanted to also thank him for accepting our invitation and to share his knowledge on the automation. Once again, I welcome you, sir. Thank you so much for accepting.
So much.
Thank you.
Thank you both. Is there anyone else speaking before me?
No, sir. You can go ahead with the presentation, sir.
Thank you so much.
Thank you so much.
So let me share my screen now. Yeah, I'm starting off with the presentation, and then I don't have so many slides, but definitely I can share my experience across a good number of years with you all. So as we already mentioned, the topic here we are going to talk about, I'm going to talk about, and we're going to discuss thereafter about is the automation scope in steel fabrication. I believe I will be able to give only an overview because we are only having 1 hour, and then later on, whenever we get or we schedule similar sessions, probably I can detail it out. And my name is Abhilash Joseph. Yes, I have around 25 years plus experience in steel fabrication and software industry across different regions and countries, and predominantly in the in the Asia Pacific region. And certainly, yes, my vision, not only my vision, I believe all those who work and engage in this steel fabrication business, they all think about how to modernize the industry and automation. So thank you, INSDAG, and thank you each and every one of you for giving me such a platform to at least do something with my vision in this session of 1 hour. Thank you, all of you. And so now, when we talk about this automation scope, these are the primary segments or the major segments where we can bring in automation. Not only automate those silos and work in silos, instead make it as a common platform and make sure that these all aspects of your steel fabrication business are synced enough, and data is flowing from one to another and back and forth. So that's a whole concept of full automation of steel fabrication business.
Sir, excuse me, sir.
Yes.
I request others to please go on mute, because it is giving a lot of echo in the YouTube. Thank you. Sir, you can proceed, sir.
Thank you. So here, those major segment or major aspects of steel fabrication or the major departments of steel fabrication, as I understand, are estimation or estimators, designers, detailers, planners or planning, and procurement, fabricators, and erectors. So these are the basic or the core pillars of a steel fabrication, their steel construction industry and steel construction business. And here the whole concept of flow of information, collection of data back and forth, and use that data for your future work and current work and so on. So that's the whole concept I will be talking about. And quite often what happens, when you try to teach a steel fabricator, not to teach, I mean to introduce some solutions or some concepts to a steel fabricator, this is I'm sure that most of you might have got similar response from those type of companies, where when you go with a software or when you talk about automation, they say that, I mean, sorry, we are busy, we are too busy, we are happy to do whatever we do. I mean, so please not this, the type of wheels. I mean, simple example. So this is what happens in our industry, and hope most of you will agree with me about this problem we face quite often. Now, what's the solution here? I mean, how we can make them understand? And then, because say straight away you go and say that yes, this is our solution, they are not going to get convinced. They are not going to buy your concept. So the best way is, the first to create awareness, which is what we are doing at the moment. And awareness can lead them to some sort of interest, and then you will have a strong desire, which will lead them to have some sensible actions. So I believe, I mean, this is the most practical way of approaching the case. And let me remind you all that, I mean, we are only at that EA at the moment. We are still creating that awareness. And I believe, because when I have engaged with INSDAG several years ago, maybe 10 or 12 years ago, we were still talking about this site fabrication, avoiding site fabrication, but I can see still people are doing site fabrication, and that's a primary thing. That's a primary thing which we need to change. Sorry.
Sir, can you please mute the volume of your laptop?
Mine?
Yeah.
Right. 1 second. Is this fine now? Is it any better? Sir. Are you able to hear me?
Yes, sir.
Okay. Fine. There is no echo, and the volume is very clear, right?
Yes, sir.
Perfect. Should I repeat what I said, or it was?
Yeah, no problem, sir. No problem, sir. You can go ahead, sir.
Right. Yes. Thank you so much.
Thank you, sir.
So hope you understood so far whatever slides I showed? I mean, is there any questions at this point, or should we keep the questions for the towards the end of our presentation? Which way would
We,
you all like to
we will
proceed?
we will keep it at the end, sir.
Thank you.
Yes.
Thank you so much. So this is the basic idea here. I mean, yes, create awareness, which will generate interest, and then because interest is not enough, then the person who is leading the organization or leading the department should have a strong desire, and then which will lead them to the action. Right. So now let's see further detail it out and dig down more into what. So throughout my presentation, I'm taking this approach of showing you the problems and consequences of the current methods. At least some of the or most of the fabricators are following, and how we can improve it and what are the benefits. Right. And before we talk about it, because when we go, say, we have conducted at several instances, we've conducted a kind of analysis or surveys about, I mean, how many fabricators are automated. And quite often when you speak to a fabricator, they think or they assume that they are already automated, and their automation is either you buy a CNC machine and then you think that you are automated, or you buy a 3D modeling solution and then you assume that you are automated. But then it takes time, and effort to make them understand you are not automated, right? Your one process may be partially automated, but you are nowhere near the automation concept at all. So in that aspect, not even 5% of the total steel fabrication industry within our region, within our country, is not at all automated. I can very confidently say that. I mean, so that's how things are at the moment. Some companies, some fabricators are making efforts, but again, there
Sir,
are
once again,
challenges
sorry to
ahead.
disturb.
Sorry, yeah.
Sir, can you please completely mute that? Reduce the
It
volume.
is already on mute. It is already on mute.
Okay, sir.
Still there is disturbance, you're saying?
There was something.
What kind of? I mean, is it an echo or some background noise?
Background noise, sir, actually.
Hello?
Background noise. It was a background noise, sir.
Oh, hear me?
Sir, better you completely mute the speaker, sir. Speaker of the laptop. Speaker of the laptop. Laptop speaker is there, no, sir?
Hello?
Yes, sir.
Is there anyone able to hear me?
Yeah, we can.
Yes,
We
sir,
can.
yes. Yes, sir. Hello.
I'm not
Sir,
able to hear your voice.
sir, here,
Sir,
sir, right side bottom of the screen, there is a
Not
uh,
able to hear
uh,
you all.
volume
uh,
icon, sir.
Harish, he has reduced completely. That is why he is
Right side
not able
bottom, you can
to
see the volume
listen.
icon.
Sir, now you can present, sir.
Here, sir. Yes, not that, sir, not microphone. Next to that, third icon.
Let's try out something else.
Next to that third icon is there a speaker.
No,
Yes, sir. Oh, that you make it to 0, sir. Or you can mute it. Not microphone, sir. Not microphone. Only speaker. Laptop speaker volume.
sir, should go down or what, Harish?
They have to go down, sir. Left side bottom. There is date. No, sir. Date next to that left side. Second. Go down, sir.
No, no, no.
Volume button. Volume icon. Yes, sir. You mute it, sir. Mute it. So that you have to make 0, sir. You have to mute it. Not microphone, only the speaker volume button, volume icon of the laptop.
Are you able to hear me now?
Yeah, we
Yes,
can,
sir.
sir.
We are able to hear you. But
And is
only
there any
laptop speaker volume should be reduced. It has to made mute.
No, I don't have a loudspeaker. I mean, I only have sorry, I have, but I have disconnected now. So it's completely on the on my laptop now. I
No, it
removed
is right.
everything.
Okay, sir. You just continue, sir.
Is it
That,
what sort of sound you're getting? Is it an
sir,
echo?
actually, it
It is
is.
echo, sir. It is echo. Same, it is repeating. What you are speaking, it is repeating again.
So which means not me, someone else is having both connected. I mean, if my sound is echoing at your end, which means someone else from our viewers have both switched on.
Yes, I
That is
think
how
now
it
it
is
is
going.
okay, sir.
Okay,
You
Abhilash,
carry
you
on, sir.
continue.
You carry
Continue.
on,
I
sir.
think problem will be solved. I request all of you to just make it mute your speakers.
Yeah, if all of you can you mute your
Yeah,
I mean, microphone, I think a problem will solve. If
yeah.
not, please let me know.
Okay, Abhilash, you continue.
Okay. Right. You all hear me now? Clear?
Yes.
Okay. So the first, the pattern of my presentation is going to be based on, and you can see my screen also, I believe, right? I'm sharing my screen.
Yes.
Perfect. So my whole of my presentation will be, the left-hand side, I'll be showing you the problems and consequences of the current methodology or methods, and how we can, on the right-hand side, how we can improve and take some benefits out of it. So I will not be talking about any specific software. I'll not be talking about any specific companies here. I'll only be talking about the concepts and how you can improve this industry and automation concept altogether. So first, let us take the area of 3D modeling, design, and detailing. So this area, right now, how this works, most of you can see here, I mean, or most of the steel fabricators, either they have a standalone 3D modeling system, which is traditional in its nature, or some are having 2D systems, and some may be having some other in-house developed list automated tools or any stuff only for the purpose of that modeling, design, and detailing only. So the problems here, because when you are using a 2D system, it's completely up to the expertise of that steel detailer or modeler or the person who is doing the layout. So it can cause a lot of, number one, a lot of errors, right? And if you use the traditional way of 3D modeling systems, which are not automated enough, then a lot of excessive drawing work. And all of this will consume and leak out your time, first of all. And there is no, because you're using this standalone non-integrated 3D tools for your modeling, design, and detailing, there is no way that you can integrate it with a common platform or a common solution, such as the IFCs and other sort of the neutral files and such like that. You may not be able to do. So no seamless integration at all, which will automatically lead you to a higher operation cost. And at the end of the day, the result will be loss of your money and reputation due to all these delays, errors, site works, and stuff like that. So now the steel fabricators has to decide whether they wish to follow this pattern, or there are tools, there are software solutions which can help you do the design, 3D modeling, detailing, all in a one single platform, right? One single platform. That means, see, a design concept, or whether it is a plant or a commercial structure, all of these will start with a conceptual 3D model or a layout. So there are software solutions which can do the layouting of your 3D, the whole project or whole structure. You can do the 3D layouting, and from the layout you design, or you send that information to your design software and get that designed structural components back to the layout again, and further again you do the clash check. When I say the clash check, not only the clash check within the steel structures, but also the clash check with other equipments, piping, pipeline, and all of those, right? The entire a construction site or a project or a plant is not only having steel structures, it has several other equipments and pipelines, layouts, so many things are there, and you will have to ensure that it is not clashing with any of those additional components in the plant. So that's the key. So, and we have to, I can see that, I mean, most of the industry is not yet fully automated with that. We may do the clash check within the steel structures, but when it comes to when you go and direct that at the site, you'll see those lot of clashes which are happening with the equipments and stuff like that, which will lead to, at the end of the day, because equipments, they are very, very costly, and you won't be able to, or pipelines are, again, they are designed, and then you won't be able to move them just like that. So that's that layout you won't be able to change. Finally, what will happen? You will end up revising your steel structures, which will be at a huge cost. So this is what we are trying to avoid here by syncing all these drawing, detailing, modeling, design aspects of your steel fabrication business. So you can see that, I mean, so here there are tools which can provide, or there are software solutions which can give you a real-time clash detection, which means, see, let us assume that you have a layouting tool, which is, on which a team is working and another team is working on the design, and then one team is working on the detailing, right? All in kind of parallel, or with different areas of the building. They are different segments or zones of the building they are working. The moment a detailer makes a change in his detailing 3D model, it can come back automatically. It can reflect, that change can reflect in the layouting model, and then alert the person who is, or the team who is responsible for the layout, alert them that yes, there is a possibility of a clash with an equipment at so and so, or this specific location. So this is the beauty of connecting them together. So it is a real-time clash detection. And the similar way you can maintain the model accuracy, because at most of the times what happens when you compare your design drawing and actually what is detailed, or actually what is fabricated, and then there is a concept of as-built drawing. So when this as-built drawing, when you modify, this is not, most of the times this will not go back to the 3D model at all, because in the current situation, going back to a 3D model, you have to engage extra extra maneuver to modify that in the 3D model as well. But think about, if there is a single platform, the moment you make any changes in your detailed model or fabrication drawing, so not the drawing, I mean fabrication model, if it can reflect in back in the layout steel structure as well, so then your data is up to date and data is maintained forever and ever. So that's the whole concept which you have to I mean, that means at least when you talk to the steel fabricators, this is what you have to communicate them, right? You are automated in the detailing, but and individually, they're all working in the silos, right? I mean, a design silo, detailing silo, modeling silos. So these are all different, but they are not always connected real time. So we have to bring in that change in the industry, make sure that yes, they are synced in real time. And let's see the benefits of it. Yes, we said, I mean, real time clash and model accuracy, which will naturally lead no data loss at all, no editing, and more importantly, retention of the intelligence of that model. That means anytime in future, if you want to build a similar or slightly different plant, without any fear, you can go ahead with that first model, the conceptual layout model, and proceed with additional modernization or additional changes and stuff like that, because you know that even your layout model is fully up to date, as built. It is in the form of what you built at the site. So and again, the change management becomes so easy because you need to change only at one place, and rest of the changes can happen automatically by syncing. So the whole process will become very, very easy, faster, and very profitable. So this is what I would recommend to the steel fabricators when we talk about the modeling, design, and detailing automation concept fully. And this is not only connected between this modeling, detailing, and design, further connected with other, the execution side as well, which we will talk in the subsequent slide. So now let me move on to the next one. So this is where we have to talk about the first stage of your construction process. When you do the bidding, estimation, costing, and stuff like that, you need to assess. So right now, the current practice, as you can see on the left hand side, most of the times I've seen, I can confidently say, at least 99 out of 100 steel fabricators in our region are still using this for their estimation. They calculate everything on the basis of just percentages, irrespective of the type of structure, irrespective of the kind of the shape of the structure. They have a standard percentage for their overheads, standard percentage for their labor, and standard percentages for their wastages. They are not calculating that in the real time. They just, that means in a simple language, you say that, I mean, they are just simply using the thumb rule. Rule of thumb they use to calculate their cost of the structure. So what are the problems there, or what are the consequences of doing this way? Most of the fabricators may say that, yeah, we are okay with this, right? I mean, yes, they are okay with that, because they are not trying out anything new, and they are okay with it. And they are not realizing that, I mean, at times they are losing out to their competitor just because of this reason. They often complain that, no, today's date, I mean, everybody is undercoating. But actually, they may not be undercoating. They have a proper system in place to calculate the actual cost, which will make them realize that, I mean, yes, we can make massive profit at this amount as well. I don't have to. So it's always better to have a proper system and win the project, rather than quote higher and lose the project and say, yes, you had a better margin there, but if at the end of the day, if you are not winning the project, what's the point of that margin? So there is no point at all. So here, I mean, that's what I'm listing down here, the consequences. Non-competitive. Your costing and your estimate is going to be non-competitive, which means your competitor will always win the project. And this whole process itself is time consuming, because everything you have to calculate on the basis of percentages, spreadsheets, and then so many things. I could see that, I mean, there is no simple solution here. So it's time consuming and very unclear profit margins, because you have to cross your fingers and wait for the end of the project to see that, I mean, and is there any other risk? Have you calculated this, that, etc.? So profit margins are very, very unclear here, right? I mean, you don't know, you don't have a clue. You simply added the percentage, but you're not sure about those percentages even. So it can make you, it is at high risk actually, because it can go either ways, right? You think that, yes, your percentages are foolproof, but at times, if it is a complex project or a lightweight structure, these all percentage calculation may go wrong. So it all depends on so many other factors. And the other thing is inconsistent, because you are not studying the 3D model, or because you are not analyzing other data which is alongside your structure or design or model which you prepared. Your profit margins and your estimation is always going to be inconsistent. And finally, as I mentioned, what it will lead you all to is your loss of your money in case of, loss of your money in case if you're not properly assessing your profit margins and such like that. And then if you are using the thumb rule and then overquoting, then definitely failed bids, because today's world is very, very competitive. The customers who offer a precise price will win the project. So that's what it is. So now, what is the solution here? So I'll talk about the solution here. I mean, I'm not only talking about the problems, and then the problems I'm only mentioning to keep people, keep them, or let them open their eyes and then see what's happening around the world, and then or where they are losing the money. So now, and about the solution, see, as I said, I mean, your 3D model is at the time of that layout structure itself, you have a 3D model ready, right? So why don't you take that? And there are tools available, there are software solutions available which can absorb a 3D model and the data information from there and calculate on the basis of that. That means you can introduce an estimation and costing software solution within your organization which can read data from your 3D model and then read the data from your past experience. But how will that past experience comes into the system, I will explain later in my subsequent slides. It is not that something which you add manually. That's what I said. I mean, data. I mean, because today's world, the most important component of your business is data. Whichever way you can use your data, because you have everything, right? You have everything. When you execute a project, when you construct, when you fabricate a building, when you erect a building, you have some data. But the only problem right now is that you're not preserving that data. You don't have any clue or how to standardize that data. I mean, that is what software solutions can take care of. Collect those data and preserve that for your future bids and estimates. And the whole process, I will explain you in my subsequent slides, I mean, how that happens and what sort of solution we can implement there. So here, the three basic concepts here, as I said, the labor and production cost, material and wastage cost. That means wastage means material wastage, and overheads, your company overheads and stuff like that. I mean, mainly those are, majority of those are fixed. But these two components, material wastage and labor and production cost, are highly dynamic. It is very much dependent on the type of structure, and type of quality requirement of that specific customer, and so on. So there are so many things which you can do in order to fine tune your estimate and cost of the structure. And how it is going to benefit when you implement these all systems. I already spoke about the majority of the benefits, but if we summarize those benefits, it's very quick and easy, very less effort, because it's all done by the machine, and data has been collected from your previous project if you have executed that by using an automated tool. And your bids are going to be highly competitive, right? Literally, nobody can sensibly beat you with the price. And because still there may be this type of companies using the thumb rule without understanding, they may quote a project lower than you, but you can make sure that they are losing the money because their bid is not correct. So it is equally, I mean, losing a project which is going to cause you a damage and loss is also equally good for your business, right? I mean, there is no point of taking a project on loss. So that is where this solution helps the steel fabricators, and very clear profit margins. The moment you cost system can show you what is the expected profit in terms of money. Clearly it can show, and your bids are going to be very consistent based on the structure. And profit margins are going to be very consistent in that aspect. And costing based on portfolio, right? I mean, certainly, I mean, portfolio, what I mean here is the type of, the costing will be highly dependent on the type of structure, because the costing method or estimation method for
live streaming is on.
Sir, you can go ahead, sir.
Thank you. So overall, you will have improved and sure short profits, and your success rate of your bids are going to be much improved, and a better rate of success rate of your bids. So that's going to be the end result of introducing such systems into your practice. Now let's move on. Next aspect, I mean, we have already discussed design detailing and modeling, design detailing. We've discussed the estimation and costing side of it. And now when it comes to the real project execution, the key element of a steel fabrication is how do you manage your material? How do you manage your procurement process? How early and how effectively and how precisely you can do, because material is highly costly, and in today's market the cost is highly fluctuating as well, right? So there is no point of the last moment. You have seen that in the past 1.5 years the cost of steel has massively increased and now suddenly dropped as well. So that's the kind of market. So it can be very dangerous if you're not doing a proper material management and timely procurement. It can affect your project, and it can at the end of the day it can affect your profit margins massively. Right. So let's talk about the problem side first. Problems and resulting consequences there. So here again, the base problem here, material management, sadly, in most of the steel fabricators I've seen, either they stock excessive structural components and they modify the design or fine-tune the design to make that structure. I mean, at the end of the day, someone is losing the money there, right? By changing the design and going for a higher section size because it is available at the moment at their stock. Someone is losing, someone has to pay for that extra weight, right? So somewhere you're losing that money. So, and then the base concept still remain with the steel fabricators. They go with the rule of thumb. They go with the rule of thumb, their percentages of wastages, their percentages or their type of structures. And it is all, I mean, you know that, I mean, in most steel fabricators I have seen, I have worked with and have engaged with, this material procurement list and such like that is the most confusing and challenging part. I mean, last moment you will see so much rush for that, this and such like that. I mean, this material is not available, that is not available. So the reason is this, right? I mean, they all doing their material management based on this thumb rule, right? So the main result of that thumb rule application is shortage of material or excess purchase. Both are equally loss making for the organization, right? Material shortage means last moment you have to compromise on the price and then get it from somewhere and then fabricate. Excess purchase, you may have to wait for another project with that type of sections requirement, and your money is dead there. You won't be able to invest it anywhere else. And last minute rush, right? So sometimes you think that you have sufficient enough material, but at the end of the day, because you don't have a proper material management, you allocated already procured material for another project or a similar project or a different phase of the project, which can again result in a last minute rush for the material procurement. And more importantly, there is no way that you can trace these things, right? Where it went wrong, who made the mistake, so that, I mean, it is not to penalize that person, but instead to rectify and correct that for the future. You don't have any way. So that means you will not improve at all. I mean, you will continue with this, or you keep on doing these mistakes and keep on getting this trouble. And you know that, I mean, a material shortage or a last minute rush can always cause a delay in the project, right? And today's world, timelines are very, very important, and otherwise you may get blacklisted, or, I mean, maybe the delayed charges and stuff like that, I mean, you will always get. So that's another consequence of this thumb rule method. And further to summarize, again, what it causes is loss of your money, your own money, or your own profit margins. You have to compromise, and due to project delays and stuff like that, I mean, you get a bad reputation across the customer base. Now, because if you have a solution for this, then if you have a solution properly, then why you have to go for this thumb rule? I mean, just because your software solution will cost you some additional money, but you are not realizing you are through these losses, you are making at least 100 times more loss than you invest in a software solution. So, but most of the times, the sad part is that, I mean, fabricators are not realizing that. They think that, yes, these type of losses are quite natural, we can't avoid it, right? But actually we can avoid it by implementing a proper system. So let's see how this happens, right? See, in a project execution, there are 4 stages where you can get a proper data from a 3D model, or in the form of an MTO from your 3D system, right? So there are MTO at the stage of, that's the benefit of it. If I go back to my previous slide where I spoke about the estimation and costing, at this stage, you're actually calculating your material requirement item by item, because you are reading it from the 3D model. So that MTO is not full materials are included, but majority of the materials are going to be there in it with its proper actual length and stuff like that. So there are solutions which can manage your material by doing an inbuilt nesting process, both 1D, one-dimensional, two-dimensional, and three-dimensional nesting, and suggest you the proper actual material requirement. We all know that, I mean, material you can't buy piece by piece. I mean, they are all having a standard length or size, say 6 meter, 12 meter, 9 meter. These are the lengths which are available for a linear section. For plates, it differs. I mean, say 3 by 1.5 or 3 by 2. So different sort of plates. So the key aspect here, if you can well in advance, if your solution, if your software can calculate what's the actual, what's the actual lots which I need to buy, how many quantity of section X of 6 meter, how many quantities, section Y of 12 meter, how many quantities. So you can establish a connect, the availability with your suppliers, and that's another beauty. I mean, you can set that availability, or you can set the sizes which can cost you less money, and then based on that, the software solution can suggest you, yes, go for 6 meter pieces, so and so quantity, go for 12 thick plate of 3 meter by 1.5 meter, these many quantities. So it can give you an automated result, and it doesn't stop there. I mean, that's helpful when you do this MTO assessment and then send your material purchase requisitions or purchase orders out. And The next stage can be an advanced bill of material. That means when you proceed with your detailing process again in the 3D model, at any stage you can request your detailing team to send you across the latest information, or you can sync it with the 3D model and then get the information, right? And get the optimization done, and then submit your purchase orders for material on the basis of that. Same happens when you finish release it for fabrication, and then because these are all connected, that's the beauty. You're not doing this process individually or independently. They are all synced. That means after MTO, when advanced bill of material comes, it will only suggest if there is any change in the material, or if there is any additional procurement you have to do or not. So it is precisely, it knows that yes, for the previous MTO, I have already blocked and purchased my material, and this is my extra requirement. The same happens when there is a fully released for fabrication stage, and in case of revisions also. So it's fully synced. Changes are easy, material changes are easy, and it doesn't stop there. I mean, after optimizing and releasing the purchase order and receiving the items into your inventory, this tag, that means it is already tagged and allocated. That means for fabricating which column number or which beam number, erection mark number, you have procured this. This is well stored in your material management system. So when you release this to your fabricators for fabricating, you know that whether your inventories are already tagged, and this 6-meter piece of so and so section is to actually fabricate your erection mark number 1, 2, 3, 4 from that, right? So these are all clearly defined. So that's the beauty. I mean, they're all connected. It is not that you are purchasing on the basis of you're optimizing your material requirement on the basis of your 3D model and it ends there, right? It is a continuous process, and this optimization and these 3D model are synced, and then your mark numbers are tagged on your inventory. So and then to the workshop and then fabrication, the same in case of revisions and such like that as well. So now when we talk about, or when we summarize the benefits here, number one is that you can do a timely and advanced purchase whenever you want to, right? And your purchases are always going to be optimized. And when you do a timely purchase and optimized material, definitely it is going to save your money and time. And you are definitely causing minimum wastage, because that's another thing, right? This even there are systems which can sync with your CNC machines, and based on your CNC machines capacity, right, it can introduce certain additional limits. Because say for example, your CNC machine can't cut plates beyond 2-meter width, say for example. I mean, so what will you do? So these type of limitations based on the machine specifications can be set in the system once, or it can be synced with the CNC machine. What's going to be the burning or wastages and stuff like that, you can definitely set in the system based on your CNC machine, which varies from machine to machine, right? So these are all. So you can overall it can cause bare minimum wastages and optimum inventory utilization, because inventories are tagged for a specific erection mark number, so there is no way it can go wrong. And as I said, change management is going to be very, very easy, because you don't have to do everything once again, right? I mean, system knows what's new, and then it will optimize for that new requirement only. And this is another indirect benefit, I would say, early design assistance. That means, see, when your designers are processing it, so designers are designing it, you have inventories, some excess inventories from your previous purchase, or maybe you procured for a project and that project got delayed or didn't materialize at all. So you know that some sort of inventory is there in your yard. But how can you communicate that, or how can you efficiently and effectively communicate that to your design engineer? This is where the system helps you in that as well. So your design engineer is, that whole system is synced. So your design engineer knows that, yes, okay, my company has ISMB section so and so, or 6 meter, 10 pieces left out in our inventory, which is right now not tagged for any project. Why not me fine tune my design to use those sections, again causing benefit for the steel fabricator, his own company, causing benefit for his own company by fine tuning his own design, and that too through an automated manner. So that can result again further a benefit for the organization. So that's about the material management automation side. Now it comes the most important part of the planning, right? I mean, so how planning can be automated. So again, when we talk about the problems in the planning side, I would say that, I mean, most of the steel fabrication projects, no planning at all, right? As we hear that, I mean, people are fabricating at site, and then so how can you plan if you're fabricating at site, right? So you are doing site welding and so many things. So literally no planning there, right? Or if at all you're planning, majority of the fabricators are using some history data which is there, but again manual, and they are using thumb rules, or some of them are utilizing, because for some steel fabricators automation means ERP system, right? And nobody understands the real thing, that I mean ERPs are just transactional softwares, right? I mean, it's mainly to manage your the money flow and stuff like that. It's highly finance oriented and highly transactional. What you enter, it will reflect there. That's all, right? So it's more like a monitoring tool rather than an execution tool in that aspect. So if you're using these type of solutions only and thinking that yes, you're automated, these are the consequences which are awaiting you, I would say. Excessive subcontracting, because you are not planning sufficient enough. So at the end of, at some stage you realize that your company is not having sufficient enough capacity to execute this, no sufficient enough machines, you don't have sufficient enough yards and sufficient enough employees, so you won't be, so you need to subcontract. Subcontracting is always going to be expensive, because unless you consider that in your estimate that yes, I will be, these are all surprise losses and delays in the project. Workloads are uneven, some machines and some areas and some people or some laborers will end up being overloaded, and some others are underloaded. I mean, you never come to know about it because you don't have a system to properly distribute this work across, distribute this material across. And finally, I mean, whatever you plan or whatever you assume or whatever you hope and expect, nothing is going to be near to the actuals. Everything is going to be unpredictable. Again, loss of money and reputation. The most fatal thing for an organization is loss of money and reputation. Reputation is the most important fact in steel fabrication. We all know that, right? So how can we solve it? And how can we take some benefits, right? You know that, I mean, you've yes, CNC machines nowadays, I mean, many steel fabricators are using CNC machines. I can see that. That's of course a good move, but you're not using that fully, right? I mean, you are using, yes, you are saving some labors there, right? I mean, but nothing else. And so you have machine specifications. So combining the machine specifications, resource load, and resources efficiency, and parameters from the 3D models. These are the concepts, or these are the aspects, I mean, which automated planning tool designed for steel fabricators will use mainly. And how would you get this resource load? It is all, as I said, I mean, data, the whole data is flowing back and forth, right? From your CNC machines or from your previous planning project, everything is in one system, right? So your system knows that yes, these many laborers are allocated for the X project because system is assigning it in the process. So it knows. And then similar way, the resource efficiency. This is most important. I mean, so resource and machine efficiency. I mean, resource means not only the labors I'm talking about. There are machines. Some machines are having some restrictions, another machine is having that restriction. So at the end of the day, the efficiency of your resources. While planning, I don't think, I mean, at the moment, nobody is actually thinking about or bothered about that, but that can cause you massive delays at the end. And I don't know how many steel fabricators I would say, I mean, not even, almost 99.9% of steel fabricators are not considering the 3D model at all. That means a detailed, fully fabricatable 3D model at all for their fabrication planning. They just go on the basis of weight or number of pieces and stuff like that, because they think that that's easy, but they are losing money. That's the result. So here, if you use a tool which can plan effectively by considering your own data, you're not setting any data there. You're not collecting data externally. You're collecting your own organization's data, right? So that's the most important thing, because when you start using the system collects this data and sends this back. Not only here, it's not only useful here for your planning, it's equally useful for your estimation and costing as well. That's what I was talking about when we discussed about the estimation and costing. Yes, this data is flowing back to your estimation and costing as well. So it can give you a better results in your estimation and costing as well. So what are the base features and benefits here? I mean, you can set your production rules, and you can automate your sequences, which means, the production rules, you can set your rules in the productions, right? I mean, it's not a verbal rule. Instead, you can implement that in the system, right? My X machine is this, and Y machine is this, and this is the capacity of my that machine. This is the capacity of my another next machine, and the sequence is automated. That means, see, over a period of time, we know that yes, where and all you have to take this piece into, because when a raw material 6-meter piece comes into the plant, into the workshop, yes, you have to cut it, and you have to drill certain holes in it, and then maybe you have to grind it, and you have to weld some pieces on it, and then you may have to weld them fully, right? And then you may have to paint it, or different process, right? I mean, you may have to sandblast it first, and then or shot blast it first, and then paint it. And painting may have different coats, different type of paints. These are all these things for a project which is well set, and it can, because automated sequencing means system can identify, because if you are loading the software solution with a 3D model or the CNC, the DSTV files and stuff like that, system knows that how many holes are there in it, how many welded pieces are there in it, is there a bevel on the end or not, right? Or how many cuts I have to make. These are all known to the machine when you load a 3D model. On the basis of that, system can automatically decide the sequence. Yes, first it has to go where, second it has to go to which machine. So remember, I mean, automatically the workload is also getting distributed, right? So these many pieces I have to send to my drilling machine. These many I have to send to my CNC cutting machine. So your plans are going to be, as I said, the most optimum plans it can give you, right? And if at all you have to subcontract, it will show you, yes, you are overloaded. Well, in advance, it shows you that, yes, your plant can't manage this. As I said, at the stage of estimation and costing itself, this project, you won't be able to manage with your own capacity. Either you increase your capacity, or you be ready to subcontract it. So it's not, so you get enough time to get quotes from your subcontractors, and then go for the best or most profitable bids from your subcontractors. And as I said, I mean, your workload is going to be pretty much predictable, and you get, more importantly, you get a real-time feedback. So that means you can see, you can check the system and see the workload and stuff like that anytime. So it's real time. Anybody who is authorized can see, which means there is no last minute surprise. Otherwise, you know that. I mean, people, the site foreman, sorry, shop foreman or the employees, they say that yes, we will finish tomorrow, day after, but you know that, I mean, how they are progressing, right? So you know that according to the plan, no, you're not going to reach there, or you're going to be early. So these all things are very well known to you. So with that, we will move on to the monitoring side. I've touched upon that monitoring side in my previous slide already. Right now, as I said, I mean, the current problem is that there is nothing is connected. I mean, only you are dependent on manual reports, email from sites, phone calls from sites. So when you ask your site foreman or site I mean directors, they give you some sort of information which you have to believe. Even if you go and visit the sites, I mean, not always possible, right? But still, you won't be able to see exactly, I mean, how many days it's going to take and such like that. But so that means you're getting insufficient information. So your decision making is definitely going to be wrong because you don't have sufficient information, right? So, or at times you get the fudged information or incorrect information, right? And that means you know they may give you a wrong information, and sometimes they say that yes, we are delayed, but we are sure that, I mean, tomorrow we will finish, right? It's a false commitment. You don't know, and it will end up in having last minute surprises, right? But think about, and this is equally applicable in your shop floor as well as erection site. Everywhere this is equally applicable. But this is where you can implement and fine tune, you know, base it on some sort of barcode tagging or RFID tagging, and use CNC machines and mobile syncing. So these all everything can be synced together back to your 3D model and monitor within your 3D model itself how many of these are fabricated, how much percentage of this is fabricated, which one is delayed, which one is on time, whether you erected this piece or not. This will help you immensely in making your decision or making your commitments before your customers, right? You can confidently say that yes, we will finish phase 1 on so and so date. The similar way, it will help you during revision. Say, for example, your customer is or your client or maybe the project owner itself is asking you that, I mean, say we have some issues, can we change this portion of the project? Immediately you can say whether you can actually do or not, because if it's already erected, you can say that it's already erected, or it's already fabricated, or it is halfway through the fabrication. And not only that, you can communicate that status. If say then the customer says that no, but we have to change it, then you can easily cost. You can send this back to your costing solution, and costing solution can say that yes, how much it is going to cost you, Mr. Customer, right? Easily, that means the entire thing. Earlier I said that the change management is really very easy. Monitoring, project monitoring is very easy. So as I said, I mean, real time. So the major benefits: real time 3D status, and you can see a plan versus actual, right? How you are progressing versus your plan, which is the key in any project execution and monitoring. And certainly for your customers, your clients, you can send their customized reports and emails and stuff like that from the system straight away. And timesheets of the employees and stuff like that, I mean, automatically generated from the system. You don't need, I mean, it's all, I mean, and a complete mobility. You can see the status from your laptop, your mobile phone or your tablet. I mean, wherever you want, I mean, you can see open, and even you can give this access to your, if you want to be a bit more transparent, you can go to that extent of opening this up for your customer, and your customer can see the real status. I mean, they will be hugely impressed with that procedure. I mean, yes, we are open. You can see where we are with the steel, the fabrication, right? I mean, they need not even visit the site. I mean, so you're talking to a CEO of that your customers or your client, and then say, Mr. CEO, I mean, yes, we have this system. You can see what's the status, how it's progressing, and such like that. We are very transparent. We are crystal clear. So that's the beauty. And lastly, most of these solutions can or most of these aspects. I mean, I spoke about, I mean, the modeling, design, detailing, estimation, costing, planning, material management, planning, monitoring, erection, and such like that. These all can happen across the world. That means it need not be at the same. The beauty of such systems are, we know that, I mean, sometimes the steel fabricators are only fabricating it. Erection is done by someone else. Design and detailing is done by someone else. So this can happen irrespective whether you do everything or you do bits and pieces. If you implement such a system, data can flow in between across the globe, no matter who does what. As long as the system is implemented, you can see see and monitor and plan and cost. I mean, everything is very much done in that sense. So that's all from my side. Thank you so much. And now we are open for, I don't know how much time. I think because of the in between delays, I believe we overshot by 10 minutes, and I'm extremely sorry for that. Please, you may ask your questions right now.
Yeah,
Sir, first of all,
Abhilash,
yes, sir.
thank you. It's
Thank you so
excellent
much.
presentation. I have enjoyed. Okay,
Thank
sir.
you. Yeah.
Sir, you tell.
Sir, I think it is excellent information for us. I think you touched upon the estimation and costing. You touched upon the estimation and casting part, and how to grab the project, first of all. That is the main scope of the automation. If you grab the project, then only we can play with the other things. So automation, going for automation will definitely help the fabricators or any company to grab the projects. And you also touched upon the material management. Without that, a huge loss. So that thing you, and also you touched upon this coordination between the designer and the company or the fabricator. That is very much essential because, yeah, as you said, there will be some size of the material available, and the designer may have given different size, and where you need a smaller size section, you may be using the higher size because that is available with you. And that was a fantastic thing you have touched upon. And also you touched upon the planning aspect, which is very important along with this project monitoring. I think really, sir, we enjoyed your presentation. It was highly informative. Now I request Pavitra to take up the question and answer session.
Yes, sir. So first of all, thank you for such an insightful session. I have few questions. The first thing, the design and management software do help in implementation, and automation in fabrication surely requires big setup, helping huge projects. But for medium and regular projects, what are the methods available to achieve accuracy in fabrication?
I would say, I mean, my answer here is that it depends. You know, there are all these software solutions or machines are also having capacity, right? You can implement them based on your requirement, right? I mean, so if you are a company executing smaller projects, say maybe 500 tons of project, I mean, a month or something like that, there are people who can help you in layouting your whole system on the basis of that. What tools you need, what software solution you need, what CNC machines and what kind of layouting you require in order to do this. So definitely those are available as well. Did I get your question correctly, and did I answer your question correctly?
Yes, yes.
Is that?
So one more question.
Yeah.
Automated design and manual fabrication, manual design, automated fabrication. How it works in realities?
Say that again. Automated design and manual fabrication, right?
Yes, manual design and automated fabrication.
Right.
How it works in reality?
It works. I mean, I'm not saying that it doesn't work. It has got its own consequences as well, right? Say, for example, automated design, manual fabrication, right? Which means your design is automated. You have a 3D model. You have 3D model of each and every component there, right? but your fabrication is manual. So what at the end of the day, what you're doing is that you're printing a drawing and looking at that drawing and then fabricating it. So which means you are not encashing on your design and the data which is already available. You are forgetting the whole data which is available, and you are using a 2D drawing, and then one by one you are fabricating. So you won't be able to do the material nesting. You won't be able to send it through your CNC, because you are not using CNC machine. So that means your process is not automated. Every holes you have to drill manually after taking measurement. See, what's the beauty of CNC machines? Because your design and detailing is automated. So 3D data is there. If you feed that into the CNC machine knows those distances automatically, right? Where and all I have to drill the holes, it is already there, came from the model. Whereas in the manual one, you have to mark one by one and drill it. Number one, it's a time consuming process. That means it's not efficient at all. Number two, you can cause errors as well, right? I mean, while reading the drawing, you make a mistake, or while marking it, you make a mistake, gone, right? That hole went wrong. So these type of problems. And the same way, say for example, manual design, automated fabrication. That automated fabrication. Yes, you have a CNC machine, but you don't have any data coming in from the 3D model. So that means the same way you have to do CNC programming separately. Sitting at your workshop, you have to engage a programmer, and he has to make that program, but again manually by reading the drawings, right? So it's again, I mean, you're not taking any benefits, right? I mean, you're not taking any benefit. Yes, slight benefits, it is possible. Yes, you can still do it, and you think that yes, your process is automated, and because your CNC machine is cutting. So the only saving is that yes, that cutting labor, you are saving time, but you are equally spending more on a CNC programmer there, because your design is not automated. So you're not getting any DSTV files or CNC files from your 3D model. So that means you end up again spending more in that aspect. So that's my answer to it. Is that clear, very clear, or not the right answer?
Yes, sir. Thank you.
Thank you, sir.
That's all from my side.
Sir, I have one question.
Please.
Sir, assume that we have a conventional setup of the fabrication. Is that we need to purchase CNC machines for automation, or the conventional itself can be converted?
So that means traditional machines can be converted into?
Exactly.
No, there is no real way of converting the traditional machines into a CNC machine at the moment. But I think it's a good thought. Somebody should think about that as well. But I don't know how much practical it is, to be very honest. But at the moment, I have not heard of anything which can convert. That means not at the level, not at least at the level of automation we are thinking about. So that may not be possible. And it doesn't mean, see, I'm not saying any organization to go for an out and out modernization, but they have to design a modernization program, right? That means, yes, first I will buy this, or this step, next step. It's a journey, right? I mean, so at least that moment is there, or that journey, if you are starting, that itself is a good sign, right? But right now, that's not happening with most of the steel fabricators. That's the sad part. I mean, or that journey ends somewhere, right? They buy. I think that question was the previous question was really relevant, because there are many fabricators having automated shop floor, but not having any sort of automation in their design and engineering. The similar way, there are another set of steel fabricators. They are having sufficient enough automation in their design and engineering, but everything happens manually at the shop floor and site. So both are equally bad in that sense, because you're not fully utilizing or you're losing out on what you already spent on automation on one. So you have to move. Yes, first you did this, but make sure that after a certain phase of your business or stage of your business, you automate the next as well. So that's the best way.
Okay, sir. Thank you, sir. Thank you for your informative lecture. I think
Any other
now all
questions?
the, I don't think there are.
All right. Okay.
Yeah, yeah. I think all the participants have enjoyed. I think there were only 6 or 7 slides, but it was highly informative.
True, true.
That is the strength of you, I believe. I think we all enjoyed it. Samantha sir, your final remarks.
Yeah, final match exactly as you are showing. Your student may be finding little bit problematic because they don't have that type of practical exposure. But
Yes, sir.
really, once they get once they get some 1 year, 2 year experience at shop floor, they will be able to appreciate. Or otherwise, also after 2 to 3 years in their professional experience, they will be needing all these information what Mr. Ovilasji has shown you just now, because as on today they may not feel, but however those who are professionals or experienced, I think it is extremely good presentation, and for me also a lot of new things I have learned just now. But I am in regular contact with Ovilasji. After sometimes again I will speak to you personally for some other matters. But anyway, for the time being, I must thank you very much that at least you could make it happen, because I was apprehending that you are so busy with your professors, whether you will make it able to ultimately in time or not. But really, I am very relieved now, and I must thank you very much for your excellent presentation.
Thank you so much, and thanks for giving me this platform. Once again, thanking you all, and then a slide. I mean, a small suggestion from.
And on one more thing, again, I want to repeat. So, if any question is there towards Abhilash kindly send the questions to me. I will get it answered. Okay, so
Certainly,
no
I will.
problem. It is not that just 1 hour presentation. Even after 2 days, 3 days, after 1 year also, you can ask me the question. That is the job of INSDAG. We normally get it replied from the concerned person. Thank you very much.
I'll be very happy to assist you with any that sort of questions at any time. Please,
Okay.
please feel free to approach me through INSDAG, or meet me or connect me on LinkedIn. I'm very much available on LinkedIn, and you can search for Abhilash Joseph or Abhilash M Joseph, or maybe search it with AVEVA, my company name. So then definitely you will be able to get that one. And you can connect me anytime, and then let's, I mean, we can always discuss these things. And a small suggestion from my side, I mean, see, when you are maybe in the colleges and stuff like that, I mean, like Samantha ji said now, those students are actually learning the practical, the theoretical stuff, right? I mean, if you can include a little bit more practicality into your curriculum, that will help them when they go out and work with a steel fabricator or an architect or a designer. They get that flavor as well from their organization itself, and that'll be a game-changing thing altogether. So you can think about that from your curriculum point of view.
Okay.
Right.
So definitely we will consider your suggestion, sir. So on behalf of Vivekananda Institute of Technology, I thank both Abhilash sir and A.K. Samantha sir for making it possible, this presentation.
Thank you so much.
Thank you so much.
Okay, Abhilash, thank you.
Thank you. Bye-bye.
Next session we have at 2 o'clock. I request the participants to enjoy that session also. Thank you.
Thank you.